Hello everybody, welcome back. Today I'm going to be talking about something bigger than the other topics. On this mini series, and for those who aren't aware, this mini series is a bet I lost from my father. And every day for 15 days, I need to make a video about a random topic in 4 languages. So it's in English, in Portuguese, in English, in Spanish, and the most challenging form, until now at least, it's Russian. So yeah, I'm a Russian. So for those who want to go and search for a new language, and not just a new language, but a new topic to hear, feel free to do in the playlist. So we are in the ninth day. Yeah, it seems right. So we come from a long way. But that's not a topic for today. The topic for today is more exactly, not exactly more, yeah, it is how far can we go? Or specifically, what's the farthest region of the universe we can hope to reach? Well, the, the answer is kind of complicated. It's not exactly complicated, but it is a different one. But first, um, let's get to the answer. Okay, so first, one thing first, we need to understand that the universe is constantly expanding. We probably learned this in school, I think, I don't remember. I learned this, I think, on the internet. Basically, the idea is that dark matter is somehow, we don't know how dark matter works, what it exactly is. It may not be a physical thing, or maybe even a thing. It may just be a variable in the universe. But it's basically something that's pushing our universe to expand. Not just to expand, but expand faster and faster every day. And basically, that means that we that means there are a lot of empty space on space. So the problem is that with that, with this uh, ever expanding universe, one very interesting thing about the variable applies is that for some reason things don't like to be dense. They like to be expressed. Like energy itself and mass likes to be spread all over the place. Just like a liquid. If I could think on a resolution like our resolution, but an example would be a glass or yeah, a glass, a cup of glass or a bowl of glass. That's for some reason, but don't think about logic. It just expands. Now think of the water inside it. The water inside it will every day until it's expanding will be uh, more and more close to the bottom. Always closer to the bottom. But let's think about our universe, like galaxies, and show us pieces of ice. If you done this example, I don't know how, but congratulations if you made ever an expanding bowl. But if you would make this example, this thing to work, the ice would expand out. So that's basically what happens in the universe. Or stars and galaxies, no, the galaxies are always and always um, expanding over and over. Everything basically. It's like a very interesting concept, I would say, that because it's expanding, the rest of the galaxies, the rest of the supercluster of the galaxies, will farther away from us because they're not gravitationally bound. In this situation, I would say, in like my every spinning bowl example, I would say there's like tiny leashes on these ices, so they can be close together even if the rest expand. But not all of them are gravitationally bound. So it happens that everything is spinning. And so that brings us to our limit. What's the limit of humanity? Well, it's about our local world. And let's actually search this galaxy local group size. If I just search this, it's Yes, it's big. Okay, I'm judging. Our local group, which consists of the Milky Way, the Andromeda galaxy, and I think 50 others dwarf galaxies, makes up 10 million or 9.8 million light years, which is not a lot. Let's be honest, it's a lot. But the problem is this equates to, if I remember correctly, 0.0000001%, or about these zeros. It looks like exaggeration, but it's really not exaggeration. It's a tiny amount of universe we can ever hope to dream to achieve. Because the question is, with this ever expanding ball in this situation, let's imagine it's a boat. The boat is humanity, okay, or expanding. The problem is the boat is ever expanding and trying to get the place to the next ice or the next galaxy, not the galaxy, but the next the next group, the galaxy group that's not gravitational bound to us. It's moving out further away and further away. We could theoretically maybe even pass our local group, but not much farther than this. Because you need to consider that not just it's ever expanding, but it reaches some places that expands faster than light itself. For example, have you ever wondered what's the size of space? Because one interesting thing is that the space, the observable universe, is 30 billion, 30 13 billion a billion, not years, but billion light years. So it's a lot, it's very big. But the question is, why we can see more? Because in mathematics at least, that's what we know about for the now, is that on the borders of these 13 billion light years, our universe expanding even faster than light itself, considering, um, each other, local groups, actually super, yeah, actually things we don't know about the universe yet. So it's kind of, it's not exactly complicated, I would say, though it is, but it's kind of interesting to think about that. We can just see maybe a tiny percent about of your universe, but we can't really do much with it because we are confined to in our observable universe. We are just confined to about our local group of galaxy, which I would say is not that bad. We have trillions of stars, some, I don't know, quintuples of planets. We have a lot of things to explore. Really, I think we won't run out of shortages of what to do. We just like the curiosity of, wow, what could be beyond this, it's not gate, but beyond the limits of humanity. Um, which is a really interesting study, actually. For those who wondering, one day we may suffer that kind of universe death because of this ever expanding one. The one I think is the most interesting, though the most depressing, is that this expanding of the universe will be all around more faster than the speed of light itself, all around. So we the gravitational bound will be ever so weak, will grow weaker by every day, and we get a point where stars can hold the planets by gravity, and the star itself can't hold itself by gravity, so we just tear apart slowly. And this will also happen to planets and everything else. And because when the universe becomes faster than light in our round expansion of universe, then in this situation there won't be any chemistry or anything because our particles, probably photons, will won't be able to touch each other because, for example, if I have two photons here, but the expanding of the universe is faster than the the, than the speed of light, so they will never touch. Nothing will ever touch. So I mean, it's kind of depressing, really, but this is only one of the options. like the three main options, and it's not even the most widely considered one. But I think it's the one cooler to say at least. Like it's not the one the more happiest, but it's definitely the cooler one. So I think that's it. Our limit again is probably 10 million years, light years, because of our local group. So it's not that bad. I think we can explore a bit. And we have a lot of time to explore, considering it's 2021 and we're just hoping to go to Mars to not even leave our solar system in about 4 years for now, which I think is still pretty quick. But you know, there's pretty a lot of time, but we need to work on it. So yeah, maybe we be able, you and me, be able to see or maybe even participate on the first solar system travel. Who knows? But until then, well, that was my video for today. Hope you liked it, different topic. I got something out of my mind as always. But if you want to suggest any comment or any topic down below, if you want to talk about the universe and space stuff, which is definitely something I like to do a lot. Um, put in the comments, send me a Facebook message or I think Instagram. I will try to use Instagram more. People are using Instagram, so I shall use Instagram for the day. And I think that's pretty much it. Um, and again, feel free to share any messages, and that's my video for today. Hope you like it, and see you later. Bye!